Welcome to the Probability Podcast. Discussions on emerging and converging technologies, problems that are being solved, and the probability of positive and negative outcomes that we might expect. Now, please welcome your hosts, Jason, the generator Spracklin, and Patrick, the discriminator Lozon.
Hi everyone. The topic for this week is autonomous vehicles. AI and the Internet of Things are advancing autonomous vehicles by improving real-time decision-making, safety, and connectivity with infrastructure. While these technologies enhance navigation and traffic management, challenges like legal issues and safety concerns are delaying the full adoption of autonomous vehicles. So, the questions for discussion today are, what are the latest technology trends in autonomous vehicles? What sort of evolution will we see in taxi services and public transit? And what challenges and concerns will impede mainstream adoption? So what do you think, Patrick? Are we ready for Kit 2.0 and Johnny Cab?
Hello, I'm Johnny Cab. Where can I take you tonight?
Drive!
Would you please repeat the destination?
Oh, anywhere, just go!
Please state the street and number.
Shit!
I'm not familiar with that address. Would you please repeat
I'm not familiar with that address. Yes, that's great. And of course, just for the people who doesn't get it, Knight Rider, right, is Kit 2.0. So,
Oh yeah.
Yes, that was a 1980s series. Okay.
Johnny, the clip there was Johnny Cab from Total Recall, starring everybody's favorite California governor, Arnold Schwarzenegger.
Yes, indeed. So where are we going with this, right? Let's talk about the control systems on these autonomous vehicles, right? Are utilizing AI. That's one of the big changes that have occurred, and that's really helped from a point of view of being able to process, the infinitesimally large amount of data that's feeding into these systems on a continuous basis all the time. And the idea too is, being able to utilize and build models around, all these different objects that they encounter, whether it be another vehicle or a pedestrian or even a traffic sign.
Yeah, you're talking about like multimodal inputs, right?
Yeah.
When it comes to computer vision and those types of technologies, you have these multimodal inputs. So now it can kind of survey the scene and understands what's in front of it and can sort of react accordingly, right?
Yeah. And these autonomous vehicles, I mean, the idea is that they're not just using one type of input either, right? We have our eyes and our hearing. Mainly, we rely on our vision. I guess the feel of the road, stuff like that. But what do they use, right? They have to use many different inputs. There's cameras. They use a different form of radar. There's LiDAR. And there is, in some cases, they do use other methods, right, of input. But that all being said, LiDAR's actually a pretty effective method to capture information. The big thing here, of course, is, like I said, is it's all about processing speed, right, and being able to attack the data coming in and respond to it, right. I think one other point I can raise is the fact that they're utilizing AI, different AI models like convolutional neural networks in order to build these, very complicated AI models that can represent, kind of the real world that they're driving through.
Yeah, so these convolutional neural networks then, maybe we can just explain that out a little bit more. It's the underlying technology powering things like computer vision.
Yeah.
Right? It's a sort of a deep learning algorithm designed for processing grid-like data, like images. right?
Yeah.
Where it needs to understand things, I guess, sort of spatially, right? And being able to classify things so it knows, like, for example, like you talked about, it's looking at a person versus a bicycle versus a stop sign or what have you, right?
Yeah. And that's, that's the whole idea is what do you do with camera data? What do you do with LiDAR data? This is image-based data, right? And you have to be able to process that and process it very quickly and make decisions. So the other thing is, okay, how do you make decisions, right? And you're making those in real time. Now consider, a vehicle drive, going 60 miles an hour and something comes across the road, that, 100 feet ahead of it or so, right? What do? Right? If you're a driver, I mean, you've been driving for many years, you've got that experience to make the call at a split second and let off the gas, put on the brakes, swerve, whatever have you, right? But the reliance now is on the computer system to build that decision and then act on it, right? So we talk a lot about intersecting technologies, right? Converging technologies. And one of the key things here, of course, is the fact that automobiles have been modified in a lot of ways. The standard hydraulic systems and such, like a steering, it's now electric motors, and it's all now controllable by the computer, right? Before it was manual control only in a lot of different systems, and the brake systems, you had to press on the brake pedal to press it in order to to build the pressure and apply the brakes, right? So that all those technologies in the car also had to evolve and become, as very, reliable and stable, and they work every time.
Now you have these, the electric vehicles, or you look at something like a Tesla or other vehicles, everything is completely computerized and everything's very much like instant,
Yeah.
right? There's the electric cars, you press the gas, the acceleration is almost instantaneous as opposed to like a combustion engine, which sort of fires up and then there's this sort of forward momentum that builds. Whereas with an electric car, it's pretty much like instant acceleration. So there's much more of a minute control over all these aspects of the car. Like you said, that wouldn't have been possible with a more traditional car.
Yeah. So, I mean, the idea is now you have these control systems or controllable systems. And now you have these brains on top of them, these robots, and they're basically managing, all the responses, and they're getting all this data coming in at the same time, right? So there's a lot going on, is what I'm saying, right?
Mm-hmm.
So the other idea around this is, well, how do you make a system like that safe, right? How do you make an autonomous car safe? And how many safety components do you build in? One of the things I saw just recently, where they're talking about implementing this in a number of different automobiles now, is the ability, you fall asleep or you pass out or have a health incident behind the wheel, the automobile senses it and basically pulls over to the side of the road, stops, and then makes the call, right?
Well, think about it the other way.
Yeah.
I was reading the other day as well that they've been trying to implement or roll out Tesla cars for police officers in California. This is a great idea, right? The cars, they're electric, they're efficient, they have a high degree of technology and all these things. And what they figured out was that the first problem they encountered was that when the cop car tried to pull somebody over, the Tesla thought that it was going off the road and wouldn't allow it. It would self-correct back onto the road. You can imagine when the police officer was trying to pull somebody over quickly. So there was just things like that they encountered early on that they didn't expect, which is kind of interesting that they went as far as to deploy out these Tesla cars, and yet they didn't think about this sort of self-driving correction. And that's even when you're driving, it's just an automatic thing that says, like you described, where, oh, this person's going off the road, let me self-correct it. But in this case, the police officer's purposely trying to pull off the road and the car's not letting him. Right?
Yeah. Well, you've got some interesting models that you're talking about here, right? So if you talk about autonomous, it means it's making decisions and basically self-driving, right? That's kind of what fifth level SEA decision making, whatever.
Mm-hmm.
But you can also have aided, right? But the idea is that what you mentioned was a driver makes a decision, performs an action, and that gets overridden. So that's an interesting one, because is that truly what you want, right? In this case here, no. The officer wanted
Yeah.
to pull that vehicle over, right? What's the difference between safety and intervention, and allowing the pilot, i.e. the driver, full mastery control of the vehicle, right?
Mm-hmm.
There's a little bit of concern here about vehicles now. You get one of these fancy vehicles, these computer aided vehicles, which is great, by the way. I just want to talk about the problem. I don't have a solution,
Yeah.
but you think about it. Lane change systems now, and automatic sensing systems that can cause automatic braking, and speed adjustment, right? These are all great systems for that work in conjunction with what we'll call an
Human in the
aided,
loop.
human in the loop, driver aided system, right? And driver aided system is having, we'll say augmented, safety augmentation, right?
Mm-hmm. When you look at some of these systems, they're built to help us in situations when we're less than perfect, right?
Yes.
When we
Yeah.
didn't get a good night's sleep the night before, we didn't have enough coffee in the morning, we rushed out the door, our senses are not at their fullest, right? And then we end up in a situation where that lane assist, or the warning or whatever it is, kind of alerts us to something we wouldn't have normally seen. Um, so I think from that perspective, it's interesting because there's sort of a school of thought of, okay, we have these autonomous vehicles, and now humans won't be driving, and is that a good thing, right? There's all the safety concerns around AI and all these other technologies, but if anybody's spent a fair bit of time commuting on the roads, in some cases, I would trust the AI or the computer more than some of these humans that I encounter on the road, for example, right?
Right. No, no, you're right. I mean, you think about it, like the computer will act reliably, and it often will be able to react faster than the human, right? And it
Mm-hmm.
will it will so it'll react safely, it will react correctly, and it will react faster, right? So, I mean, you think about the safety aspect of a computer aided, driving system. Yes, so you're a little tired. Now, I was in town on the weekend, and my wife and I were walking out to our vehicle, and behind us, right, I didn't catch it, but I heard it and then turned.
Mm-hmm.
But what I suspect happened is one lady had basically decided to turn, and she basically turned in front of a vehicle coming, an oncoming vehicle, and head on, well, side on collision.
Mm-hmm.
Now, luckily, this is at 50 kilometers an hour or whatever, what have you. So, I mean, they both walked out. They were both safe, but they were having a bad day. I mean, I would say that their cars were not were both mangled. And when you think about it, what really happened there, right? And what really is the root cause of all these, accidents? You really think about it. How many accidents you've been in or around? People are just making stupid mistakes. They're just not paying attention, whatever. And these systems can help you, right? You in this case here, this person decides to go, but there's a vehicle coming. It would automatically stop, right? It wouldn't let you go, and that
Mm-hmm.
brief second, the oncoming car passes, and right, I we didn't have that accident, you
Kind of
know.
reminds me of when I was getting my license when I was, a young boy, I guess, right, 17 or 18 or whatever age I was, and my father was trying to teach me and kind of got a bit frustrated with the personalities between father and son, and he decided to hire a driving instructor to run me through some things and just kind of fine tune things and get me ready for the test, as it were. And this car that the driving instructor used was set up so that the driving instructor had a brake on his side, on the passenger side, for good reason, because I still remember vividly to this day me about to barrel through a stop sign and all of a sudden the car violently stopping, me not realizing that there was a brake on the other side. Thankfully there was. So like that was the
That's
old
great.
school version of the onboard computer, was my driver instructor making sure that I didn't pull out into traffic where there was a stop sign there that I was supposed to stop for. So.
Yeah, that's great. Yeah, I mean, really think about it. If you had your little buddy there, your little, robot buddy looking after you while you're driving,
Johnny Cab.
little Johnny Cab, and he's just there when you make stupid mistakes. That doesn't sound too bad, right? Now, this is not autonomous, though, right? And this is where it gets interesting, because they're trying to push for fully autonomous, right?
Mm-hmm.
The industry, the different manufacturers, and what's interesting about that is all you have to do is look over at aviation, right, and see what's happening there, right? Because that's what they're doing, right? They're going fully autonomous, right? And what's happening? Well, pilots are basically trusting the systems, because that's what they do. That they trust the systems, right? So when the systems stop working properly, and they stall out, or they're flying too slow, or flying too low, or what have you, they still implicitly trust, right? Oh, it knows what it's doing, right? But they're wrong, right? There's a bug, right? It's got a bad, it's got a bad sensor. It's some bad, set of conditions aren't being met. So the issue there is that the driver, i.e. the pilot in this case, is not really in the loop. And they're expected to be in the loop, like in an instantaneous moment. Oh, I can't figure this out. I'm going offline. I'm the autopilot. I'm going offline. And now the pilot is expected to instantly take over, right? Which is, that's a big, tall order, right? And the other thing is what's happening with pilots is they're getting complacent. They're getting bored, right? They're in a situation now where they're not expected to know and feel what's going on around them. They're not all that. What's expected of them is basically just to be a warm butt in the seat. And what happens, of course, is we get accidents, right?
It comes back to that larger analogy of over-reliance on AI, for example, that we talked about a lot, right? Or any technology where you end up with this sort of complacency where now you're no longer sort of part of the equation, as it were. But I think that I don't disagree with you, but I also think that if we race too fast towards it, I think that's where we're going to end up. I think that given enough time with, AI and machine learning, I think we could get to a point of pretty strong reliability in these systems. But there's a sort of an underlying push. There's an economic push. There's lots of different factors where these companies are now racing towards it the same way they're racing towards, AI solutions and everything else, where you already see some challenges, legal challenges against, Elon Musk and the Tesla company around. They've rolled out all these autonomous vehicles, and there's been accidents, there's been deaths, and now the Federal Transportation Department or whoever are investigating, doing deeper investigations into these situations, where I guess in some cases, they were allowed to roll out these products that maybe weren't as tested as they should be, right? Yeah. I think that's where, AI and machine learning and the neural networks and all these things could really start improving upon that and testing scenarios and, increasing the reliability of things. But we already have, companies, I don't mean to single out Tesla. There's lots of companies out there producing, these autonomous type vehicles. You have this Waymo company that's producing autonomous taxis and things, but they're full steam ahead. and not saying that they're not doing testing and things like that, but I think there's a lot more prudence needed before, like you said, we go fully autonomous before the technology's there, right? It's sort of the chicken and egg type analogy, right?
Yeah. Well, I mean, there's a couple things to consider, right? If you're taking a taxi and you're exceeding 80 kilometers an hour for a sustained period of time, right? High speed, uh, collisions are less survivable, right?
Mm-hmm.
So if you're in town, you're going stopping and starting, you're going up to 70 kilometers an hour, maximum. The risk is lower, right? Now that's one thing. The other side of it is if you compare the control systems on an airplane and all the sensors it has, its job is to stay up in the air, and sure, it deals with wind turbulence and humidity and storm cells and things like that. You've got varying pressure and all that, but it's not even close to a vehicle that's on the ground going through a town, like a busy street, right? The amount of different scenarios that are occurring that are going to directly affect you as a driver or you as the robot driver are incredible, right? And as a normal driver, we usually do a pretty good job of managing all these risks, right? Oh, this kid's got a ball. Oh, no, actually, look out in front of you, in between the two parked cars, ball runs out, right? What are you going to do? Oh, let's just keep driving. No, you're slowing down to a stop. Next thing you know, the little kid runs out and grabs it, and out they go, right? And it's like, well, how did you know? Well, the thing is, that's that leap of decision making, right? And we also, as a human drivers, think about the challenge of the unwinnable decision, right? So you're driving down the road. Let's say, your passenger's a pregnant mom going down in an autonomous vehicle, and a kid runs out in front of them, right? So in that tiny instant that you had to respond, one is you plow into the other side of the street or either side into a parked car and possibly kill the passenger, right? Or you slam on the brakes, and you can calculate this, right? You won't stop in time. So what decision are you going to make, right? Mm-hmm. And as a person, right? As I'm not saying a person driver will always make the right mistake. There is no winnable situation here, right? But the idea is that that person will say, okay, I'm the driver. I'm going to sacrifice myself over hitting that kid, right?
Some is just instinct, right?
Yeah.
And then in that case, the instinct might be to swerve, and it might cause harm to yourself, but you're making an instinctual decision.
In a
split. But then I read, for example, I read about another incident though where somebody was driving on a highway, and some sort of animal, it might have been a dog, or a cat even, runs across the road, and this lady slams on the brakes, and she causes a 6-car pileup, and I think somebody actually died in the accident, right? So she made this instinctual decision that she didn't want to hit this, what might have been a family pet. And the end result was that she ended up injuring and I think actually killing somebody, so it's, again, there's sort of two sides of the spectrum, right? And sometimes these are edge cases, and that's maybe where this technology needs to get better in terms of, a kid chasing a ball across the street is a little bit of an edge case in that it's not something that's going to normally encounter every day. But then if you don't train it on the edge cases, then there's that probability of, disastrous outcomes, right?
Yeah. So, I mean, we've got a lot of decisions that need to be made very quickly on a continuous basis. And that's a high demand, a high load on, the control system, right? So how can you make this even safer in this environment, right? If all the vehicles, right, were automated, right, and they all talk to one another, right? Just bear with me here, okay? You wouldn't really need streetlights, right? You wouldn't need to have all these traffic control systems because the system, each automobile would essentially talk to the other automobiles. It would know if there's an automobile coming, if there's a gap or not, and you would just merge in, right? Or you could cross the street or what have you. And the idea would be, the systems, if they did talk to one another, they wouldn't be a light. It would just be, the control system saying, it's this, this street has a right of way. This
Will be a
traffic
virtual grid, right? There'd be a virtual grid in the software, and it would coordinate based on that. But then everything becomes more like transit, right? As opposed to some sort of ability to control your whereabouts. You're getting into a car and it's getting you to where you're going, but you have much less control over the sort of the path and the direction and that type of thing, right?
Yeah, and also you think about the driver being the being the computer system that's tied in to all the other systems out there and talking to one another. It's also very aware of what's happening, many streets down and so on and so forth. So you have that advantage of rerouting in that, and then you don't have the major, traffic jams and forming, right?
Well, that's where you get into the Internet of Things, right?
Yeah.
The sort of connectivity of everything. And so, I guess full disclosure, I started working for a company that operates in that area of intelligent traffic systems, for example. And, what you're describing is true, but I would also say that there is the ability to have that mixture. So part of the technology for the company I work for, they have the smart cameras with computer vision at the intersections, right? And they're monitoring all of the moving vehicles and bicycles and pedestrians. So, even what you described makes sense in theory, but you'd still need some system of whether it's cameras on the vehicles or cameras in the intersection. In this case, we have cameras in the intersection. We have computer vision. We have everything communicating to a central hub. So when you think about it, if you start combining that with this sort of newer technology called vehicle to everything, where all the cars are, connected to a central point, and then that central point is connected to the grid, connected to the computer vision. Now you have this intermixing of inputs into the system. So you could have fully autonomous vehicles. You could have vehicles that are being driven as long as they have a computer on board. And then you have the cameras with computer vision at the intersection. So now everything's fully monitored, and you can do coordination and detection and all these sorts of things, and even preemptive moves. And you can predict areas where there might be accidents and avoid them more proactively. And I think that's where it starts to get, it starts to evolve beyond the idea of, okay, I have this single car that has cameras and sensors and it's reacting to everything around me. Now that car is connected to the central system that has a whole bunch of different inputs and can now make decisions based on many different factors, not just what it sees, but based on its knowledge of everything else around it. And now you have this sort of ecosystem that everything is plugged into. And I think whether we get to the point of full autonomy or not, it's really interesting where things are going in terms of that Internet of Things and the connectivity and vehicle to everything, and what it's really going to mean, even for things like safety and improving traffic flow and reducing emissions and a million different areas that are dramatically needed in our cities for sure, right?
Yeah. I mean, you've talked about a lot of different things there, and the idea being, of course, is that one of the biggest benefits of a lot of these systems it's about traffic flow, right? And the idea around there's many mathematical models on flow systems and studying of flow systems, and these systems that are basically managed and run in this chaotic manner by humans, right? And how things are, it's funny. I don't know if you've encountered this, especially on the 400 series highways. you're driving along and all of a sudden there's a traffic jam. You're slowing down. You're saying, what's going on? And then everything speeds back up again. And it's this latent slowing down effect that's occurred because of a problem, an hour before. And it's really strange stuff that occurs, right? So, when you think about it, the idea of these systems actually talking to one another, the automobile systems, and having kind of system, or we'll call them traffic control systems for now, managing the whole picture. I mean, in a way, it's a lot safer than the chaos that occurs today, right? By the individual, right? And that's where the challenge is right now. Is we have to, whatever you have. If you have an autonomous vehicle, you still have to deal with the chaos of us, right, out there on the road, turning when we shouldn't turn, or not looking on something when we're backing out, or whatever, what have you.
We're not anticipating, right? We're plotting our route, and then whatever it is, the GPS or Google or Waze says, here's the most optimal route, and you're kind of following it. When something happens, it doesn't always recalculate quickly enough, right?
Yeah.
So you just sort of end up in that congestion or in that jam. Whereas when you get into this idea of Internet of Things and grids, it could proactively identify much more quickly. It needs to sort of reroute you and say, no, you need to turn here now, and you could avoid those sort of jams from happening, more proactively, which I think is an important aspect of it. I heard somebody describe to me once that traffic flows like gas. In other words, people thought it kind of flowed like water, right? That when some piece gets jammed up, that it sort of flows like water around it. But in fact, it actually moves like gas when there's sort of issues. Everything kind of disperses out through different paths, and then that in itself can cause chaos. Like in the city I live in, there's a main highway that sort of goes through it, and when something horrendous like a big accident happens on the highway, all the traffic starts filtering out into our neighborhoods and into our service roads. And so it's like all of a sudden you're trying to get somewhere that you think should be just a normal drive, and now you're stuck in this new jam that's being created because people are trying to avoid the main artery, right? And there's really bottlenecks here where they have no other choice, but there's no rhyme or reason to it. It's just human behavior. Oh, this is happening, I'm going to get off here. Oh, this road's slowing down, I'm going to move off onto this road. And now everything starts, like I said, dispersing like gas throughout the city, and then you end up with even more problems, and you end up with all this extra congestion and issues throughout the city that was really unpredicted. Whereas if you had a smarter network determining things, it could more smartly route that traffic in a more efficient way, for example, right?
And of course, autonomous vehicles would be following the rules, right? And that's the big thing, right? They follow the rules. Whereas, we're not known for doing that as human beings, and, driving the speed limit or what have you. And I think that's where the chaos, effect really, that ripple of chaos can really enhance in a lot of different ways the situation, right? And make it worse. So, so these control systems are great. The idea of all these different sensors, though, also raise the value or the cost of the vehicle. Right, all these control systems and all these different sensors, all this complexity and all this extra maintenance and support. I mean, you're just making things more complicated and more complicated, right? And then you have to deal with the same thing that the officers dealt with, where all of a sudden now the car is doing something you don't want it to do that, right? But it's doing it for a reason, right? So I mean, the idea of safety systems and augmented safety systems for your car are great. For me personally, I think that's a great idea, but I'm not so sure I want to pay them extra amount of money, right? I'm not sure I want to deal with the extra complexity, right? And the idea is, in the end, I've been driving for many years, so, I guess if I was a new driver, and looking at this, I don't ever want to get into an accident the rest of my life. Is it going to be a good thing? Maybe. I don't know. You're a newer driver, you're more susceptible, right? I'm just talk to an insurance underwriter. It's the truth.
Basically, we've gotten very accustomed to everything being very high tech,
Yeah.
but along with that comes more expense, and especially when you're looking at fixing a vehicle, right, that has all this high end technology.
You can't afford it, right? You just can't afford to fix it.
You have, first of all, you're not going to be able to fix it yourself. Second of
Yeah.
all, you might not be able to bring it to your local garage
Yeah.
because they may not have the specialized training to fix, a certain type of car with a specialized technology. And then you finally find somewhere to bring it, and now you're paying a higher fee because now you have people that had to be highly specialized in computers and sensors and everything else. And even in cars that weren't really that advanced. I mean, I've had problems with vehicles where just a basic kind of sensor went sideways, an oxygen sensor or what have you, and now the car is like completely useless. And that's in a fairly old school type of car. Now you have everything so high tech that things can definitely go in the other direction.
So we have to find ways of implementing all these different levels of sensors and computerization, and do it at a very, we'll call it a commodity-based pricing, right? And be able to manage this and verify these systems and fix these systems, and enable people to verify and repair these systems.
Well, I think you're going to see two classifications, right? I think you're definitely going to see the autonomous vehicles become more and more prominent, especially as the technology gets better. But I think in the interim, you're going to see these more assistive type technologies, but I think they're going to become, even stronger, right? You're going to have, like I said, the more traditional type assistance giving you lane warnings, those types of things. But then in the advent of AI and personalities, attached to it, you're going to see that evolve in the car, right? Where you're almost going to have that passenger seat driver, quote unquote, that's really the computer on the car that can sort of Johnny Cab and guide you, or like Kit and Knight Rider, right? Who's sort of the his partner in crime fighting, as it were, right?
Oh, here we go.
Knight Rider. A shadowy flight into the dangerous world of a man who does not exist.
That's great. Eh? Then you think about it, the idea was, that wasn't just another character, right? In the story, the computer, right? And I think we'll get there. I think we'll have personalities and.
Well, I mean, I was fascinated with that show as a kid. I mean, just, like he would call up the Kit via his, watch or whatever he was communicating on, and then the car would show up, but oftentimes intervene in the situation to help save him or help thwart the bad guy. And they certainly, even though like none of this technology existed back then, they did a pretty convincing job of it. And they gave Kit a personality, right? Him and Michael would have conversations, and I think Kit would have like witty comebacks and that sort of thing. And I mean, I remember, it came on at a little bit of a later time. I guess I remember begging my parents to stay up and watch it. I was so sort of enamored of, I think it was the show, and it had a certain like warmth and charm to it, but it felt such cutting edge. It felt so cutting edge in terms of, it was something we didn't have at the time. And I still vividly remember, I think I still have a picture somewhere of me and my brother and sister standing in front of the Kit car. They used to have, I don't know if you remember back in the day, they used to have these car shows. I don't know if you ever went to one, but they had ones where they would bring in the cars from the vehicles from the TV shows. In fact, if you think about it, the vehicles in TV shows were a big part of the personality and the story and everything in these shows. So I remember going to a show, and they had they had Kit, right, from Knight Rider. They had the van from the A-Team series. They had the General Lee from Dukes of Hazzard, right? It seemed like, remember how many shows were kind of based around like a vehicle when you think about it? It's kind of funny.
Yeah, that's right. Eh? When you think about it, and the idea though is just think about where this is going. Like, it'd be like a video game, right? You get a car, and then you can select everything you want about the personality for your car, right? The interface for your car, right?
Oh, for sure, yeah.
Give it a sex and give it a name, and talk about all the different personality traits and so on and so forth, and a
Becomes almost like
voice.
a companion, going back to
Yeah,
our episode where we talked about virtual companions and
virtual
so on, right?
companions.
So
Yeah,
instead of listening to the radio, you'll just have your virtual buddy, your Johnny Cab that you can chat with on the way to work every
yeah,
morning type thing. But
yeah. You can
let's
just
speaking of
transfer your little virtual assistant into your car, right?
you watch out, you might fall in love with it. So speaking of Johnny Cab, maybe we can touch a little bit on the idea of robo taxis and public
Yes.
transportation, because I think that's the other side of it. So we talked a lot about the individual car, right, and
Yeah.
what we use for personal transportation, but I do think there's a wider spread application in terms of taxis and public transit that right now rely a lot on humans. And of course, this spells a sort of bad news for maybe Uber drivers and so on. And we just saw that Tesla unveiled this cyber cab
Yeah.
at a big event, which was sort of interesting in the sense that a fully autonomous taxi. A lot of people commented that it had no steering wheel, no brakes, nothing for you to manually intervene should something go sort of haywire, which really says a couple things. One, that they're putting a lot of trust in that, right? That they're saying that our technology is so advanced that you don't have a need to kind of override it with a steering wheel or brakes. And number two, I think of what it's saying, and I'm not sure they're right, but they're saying, well, the public is ready for this. And I'm
Well,
not, despite all the flash of it and the advanced technology, are people ready to get into a cabin, which basically if something goes wrong, they have no control?
yeah.
That seems to be the bigger hurdle that I think we'll have to get over, right?
So I got a question for you, right? How comfortable are you in an elevator?
Personally, not a lot. Especially when something goes wrong, when the door doesn't quite close or something goes a little bit off, and I'm in an elevator with 8 other people, which actually happened to me not too long ago. I was in a giant shopping center, and we go to get on in the elevator, and the doors close, and it didn't do anything. It didn't move, and for a couple of seconds there, I was thinking I was stuck in there.
You think this elevator, right? Just as a paradigm, right? An
Mm-hmm.
elevator, I mean, all it does is go up and down, right? Push a couple buttons and you go up and down. And that's all you do, right? But you think about it from a point of view of as the passenger with absolutely no control, right, of what can happen, right? And you multiply this by 100,000, and there you go. Then you have the robo-taxi, right? and to me, I look at this as, this is Elon's arrogance as far as I'm concerned. This is just an arrogance from a point of view of thinking that you can build a vehicle that in this time and age, right, that's going to be able to manage everything completely autonomously, right? To me, I would look at this as if I was building a company, a robotaxi company, I would be building in a remote control monitoring feature, right? Where headquarters is monitoring 100% all the time. And if something happens, they have systems that kick into place and people that will make the decisions and, manage that vehicle to the side of the road or whatever safe situation there is, and not rely completely on autonomy. Because it's just like, when we talk about the airlines, when an automated system goes wrong, it goes very wrong, right? Now, on the other aspect of this is I get into, an Uber, and this Uber has all these safety features for the driver who's augmented with these safety features. I feel a little safer, right?
Yeah, for sure. I think that, but on the flip side, sometimes like we talked about earlier, drivers can be a little bit unpredictable. So it's sort of that fine balance. But I don't disagree. I think that Elon's counting on that. A lot of people taking these robo taxis have had a few adult beverages before they get into them, and maybe they're not so worried about. They're just concerned with just getting home, right?
Yeah.
And I did read something though when I was going through some of the research around this though, that things that maybe we don't think about all the time is that they did some surveys around this, and some women actually prefer it because they're not put into a situation with a male that maybe they feel in danger, right? So they actually feel a little bit safer getting into like sort of an automated taxi, as it were. So it's all about that sort of risk profile, I guess, depending on what you're looking for. But then again, we all get on airplanes all the time and go somewhere, and we're really at the risk of, or we're at the mercy of the technology and of the pilot. Well, in some cases, not the pilot, but we sort of take that for granted in a sense. I remember my father saying, once you get in that plane and they close that big old door and seal it shut, and you're at the mercy of whatever's transporting you there at that point, right? So
Yeah.
it's
You're in the
interesting
elevator, man.
you look at it from a couple of different perspectives, right?
Yeah, yeah. And to me, I don't like the idea of losing control, right? So, I mean, that's me. But the other side of it is, where's the whole industry going, right? I mean, take it to the next step is, okay, will people own a vehicle in the future, or will it just be taking public transit? I personally, don't know how long the paradigm of owning a vehicle will last forever or not, but I like this model. I grew up in this model. I prefer this model. Maybe in the 50 years from now, it would be a completely different story, right? But not while I'm alive. That's the way I look at it. And we talk about Elon, but there's many different companies out there. I think you mentioned one already that is actually really pushing for the idea of cabs, right? Robotaxis.
Waymo.
Yeah,
Waymo. They're partnering with Uber and other companies trying to push out with that technology, for example, that's going to advance, I guess, the industry, as it were, provide more options. But there's still, when you look at it, they're still ultimately going to cut humans out of the loop in terms of if we start going fully autonomous with taxis and Ubers, you have a lot of people that rely on those type of jobs, right? Even if it's not their primary, occupation, people are driving Uber for extra money. There are food deliveries. There are all these sort of last mile deliveries. You can only imagine that Amazon is going to start taking advantage of this, right? To sort of automate more of that last mile delivery and that type of thing. And you're really back to something we talked about in an earlier podcast, this idea of, people losing jobs and, everything becoming so automated, there's sort of that sort of side, the impact
and what for?
As well.
Yeah. What's the
all
real
the
benefit?
Of efficiency and profits and everything else, right? But then again, it's, if it can become reliable, maybe it improves these systems. Maybe we can transport goods faster, especially when we get into, trains and other types of transportation that is somewhat limited in terms of the amount of people that want to take the jobs, the training involved. So there could definitely be some positive side to it as well. Like every technology, there's sort of can become a bit of a double-edged sword. But, you also have to look at some of the concerns because, we always start by talking about the potential of the technology and, the risks and that type of thing. But there's some real serious concerns that we should probably touch on as well in terms of, liability and accountability. What happens when there is an accident and what are the legal precedents? If you have, I think we talked a little bit in one of the previous episodes recently about the big debate now about whether AI should pull the trigger when it comes to like a humanoid armed with a weapon. Well, now you have autonomous vehicles basically making decisions, and what happens as has happened, like I mentioned with the lawsuits against Tesla, for example, when there is an accident, and who's at fault? Is it the people that create the technology? What do you think as far as some of the liability and accountability and so on?
Well, absolutely, right? I think they're accountable, right? If they're the ones that are benefiting, they're the ones that are financially. You follow the money, right? So they should be paying, right? And that's just the way it should be. Now, in the end, what happens typically, right, is, Joe Public ends up paying for stuff like that, right? And it really shouldn't be, right? The any loss of life or injury or what have you, because somebody, didn't code something right, or a particular safety feature wasn't implemented properly, or a specific response or a sensor was designed wrong, or a response wasn't defined or programmed properly. These are all the responsibilities of the manufacturer putting that out there. So, if companies like Waymo, want to put out their vehicle and they want to say it's going to be completely autonomous, they're going to also be responsible for it. And that means if somebody, it's just like, the fact that, we look at these planes and, the idea is that they're responsible. The manufacturers are responsible, right? And if you take them responsibility out of the loop, then what does that give you? Where's the incentive to ensure safety, ensure the product works properly, right? There isn't, right? So yeah, there has to be that self-check, that feedback system. Now, the other side of it, of course, is, the whole idea behind where the law is, and the law has got a long ways to go to catch up. And that's a significant danger, I think. That's more of a risk than anything. See, I wouldn't want to go into these autonomous vehicles when I don't understand my legal rights, right? If I get hurt by one of these vehicles, right?
Yeah, for sure. Well, I think it comes down to, none of these companies are putting out these products without, terms and conditions attached to sales, right? In the sense
That's
that
called a signing off. Oh, you just sign off, right?
Well, yeah, it's like anything. You look at anything, any kind of software you sign up for, there's always this giant terms
Yeah.
and agreement that comes up. And what do most of us do? We don't read it. We check it, we click agree, we move on with our day. Now, I'm not saying that everybody's going to do that in terms of the autonomous vehicles, but when they become more prevalent, I think people would just be more like, yep, sure, I'll sign up. I want this. And they don't think about the edge cases or some of the,
Yeah.
challenges that could happen with them, right?
Well, there is a good side to this. I'm not trying to be all negative here, but the good side is, let's say you have an incident happen, right, for a particular vehicle, automated vehicle. That incident is investigated properly and it's addressed properly,
Mm-hmm.
right? And, that's addressed throughout every other vehicle within that fleet at the same time, right?
So you're going to see a big upheaval in the insurance industry around that as well, right? Like who's going to make those decisions around like sort of the reliability of the technology and the track records? Right now, all that's based on driver behavior and history and all these things. And now
Yeah.
you're driving, now you own a car that's autonomous. For example, let's just say we jump into the future where everything's autonomous, and then it's no longer based on driver behavior. It's going to be based on the risk profile of the company. It's going to change the whole game, really, when it comes down to it. We're still in that sort of early stages, right? We're seeing a lot of advancement. We're seeing, a lot happening with AI and machine learning and computer vision and all these things. And you see companies putting out these products, and hoping that people will start adopting them. But I think that we're still early enough that, I don't think you're alone in that, You may be a little bit more resistant than people that are maybe a little bit more adventurous, and maybe they put more trust in technology because they've, grown up with it as a real integrated part of their life. But I still think people, by and large, are going to be a little bit skeptical. They're going to be a little bit concerned about, walking up and getting into a robo-taxi and, there not being an actual human in there, right? It'll be like,
You're in a Johnny Cat.
I mean, what am I doing here?
I'm sorry. Would you please rephrase the question? Huh?
How did I get in this taxi?
The door opened. You got in?
You got it. Yeah.
there are some interesting, I think right now, depending on where you live, right, it could be a little bit dicey if you're in a metropolitan area that has a lot of intelligent traffic systems and Internet of Things, and everything's really super high tech. I think there will be a fair bit of reliability. I think you're going to see that ramp up pretty significantly in the next sort of 3 to 4 years, even, where you're going to have a level of reliability, like we talked about, the vehicle to everything, the traffic grids, the smart cameras, the ability for it to have some awareness of not just what's in front of it or the entire grid and other vehicles. I could see use cases where people will trust it more and more. I do see that happening, probably at a faster pace than you would like, perhaps. But
yeah. I mean, I like the Pontiac slogan, built for drivers, right? That appeals to me, right? I'd rather be the driver.
Yeah, I'm more of a fan of the Back to the Future, where we're going. We don't need roads.
Thank you for listening to the Probability Podcast. Please join us next time for more musings from the generator and the discriminator.